Everyone, welcome to my channel. My name is RF and today we're going to solve some problems in Thevenin and Norton equivalent theorem. So let's get started very quickly. So let's start with this circuit. I'm trying to find the equivalent resistor and the voltage seen from this port, from port AB. So again, I want to see my circuit from this port only. And I want to know if I were to replace this whole part, the internal part of the circuit, with only two elements, R Thevenin and V Thevenin. And again, in other words, I want to just replace all these elements with two elements, V Thevenin and R Thevenin. And then I'm going to see my circuit again from this port. So in most cases, if we have a load here, which in this case we don't have a load here, by the way. In most cases we have a load here, so we open the circuit from our load's point of view, and we try to see the circuit from our load's point of view and try to find the equivalent resistor and the equivalent voltage seen from that port, which is port AB in this case. So let's get started. The Thevenin resistor. If you remember from last session, the Thevenin resistor is found by turning off all the independent source and then try to find the equivalent resistor seen from the port. So I'm gonna just follow all the wordings here. I turn off all the independent sources. So I have a voltage source here. How can I turn it off? I just replace it by a short circuit. And then I have a 5 ohm, a 20 ohms. Continue on. I have a 4 ohms here. Over here I have a current source. How can I turn it off? Just replace it with an open circuit. So if you want to turn off a current source, replace it with an open circuit. And here is my port A and here is my port B. It goes all the way to the beginning of the circuit. So I've got 5 ohms here, 20 ohms here, and 4 ohms here. Can you find the equivalent resistor now? Should be easy. So this 5 and this 20 are in parallel. Why? Because the heads and the tails are connected together. So 20 is in parallel with 5. If one resistor is n times bigger than the other one, the parallel equivalent would be the bigger one divided by n plus 1. So 20 is 4 times bigger than 5, so the parallel would be 20 divided by 4 plus 1, which would be 20 divided by 5, that would be 4 ohms. So the equivalent of these two resistors is 4 ohms. And if I try to simplify the circuit, I have 4 ohms now, which is in series with this 4 ohms here, and then I reach out again to my port AB. So now it's easy to find the equivalent resistor, which is my Thevenin resistor. It's 4 plus 4, which is 8 ohms. So the equivalent resistor, or the Thevenin resistor for this circuit, which is seen from port AB, is 8 ohms. Now let's continue on and try to find the Thevenin voltage for this circuit. So I'm drawing the circuit again here, so it helps me just to do all those calculations a little cleaner. So I'm trying to find the VOC, or the open circuit voltage seen from here, from this port. So the very fundamental question is, do I have current over here? Is there any current passing through 4 ohms resistor? The answer is no. So if I call it I of 4 ohm resistor, the amount is 0 amp. Why? Because this circuit is open from here. Actually, I'm going to just simplify my circuit now. I've got 25 ohms, 5 ohm, 20 ohms, and then I have 3 amps. And here, the circuit is open. And I'm trying to find the open circuit voltage over here. AB. Okay? So this voltage across VAB is my Thevenin voltage. Okay? So I've got 20 ohms here, 5 ohms here. There used to be a 4 ohms here, but as there is no current flowing into 4 ohms, I've just removed my 4 ohms. So the circuit is actually up to this point. Okay? 25 volts. If I try to find the VOC from this port, first things first, I need reference voltage. For this circuit, the best reference voltage is the bottom part of the circuit, as it's all just a piece of wire connected to each other, and I consider this point as my reference voltage. I call it voltage equals 0. How can I figure out this voltage across here? There are two rules, KVL and KCL laws. You know, Kirchhoff voltage law and Kirchhoff current law. Can I use KVL in this circuit? So for this loop, of course I can use KVL, as I don't know the current of the loop. But what about this loop? The loop of 20 ohm resistor and 3 amp current source. So if we already know the amount of current in loop, there is no worth using KVL for that loop. So the answer is no. I'm gonna use KCL. And if I use KCL at this point, let's call it node A, I can go this way for the current flowing into my 25 volt voltage source, and then this way the current flowing into 20 ohms resistor, and I already know the value of 3 amp is flowing into node A. So let's try to write KCL at node A. I call this one voltage, the voltage of node A, as VA. So VA minus 25 divided by 5 is this current flowing into 5 ohms, right? The voltage across 5 ohm divided by the resistor, which is 5, is the current based off Ohm's law. What about this current vertically going down, flowing into 20 ohms resistor? That's just VA divided by 20 equals this current that flows into node A, 3 amps. Okay? What is VA? If we follow the line, we reach out to the same point of VAB. So VA is actually my VAB. What is VAB? Yes, that's my Thevenin equivalent. So actually VA is the variable that we're trying to find. I'm gonna just multiply both sides of my equivalent by 20. Just try to simplify my circuit. 20 over 5 is 4. So 4 VA minus 4 times 25 is 100. So 20 and 20 cross out here, plus VA equals 20 times 3, which is 60. So if I bring 100 to the right side of the equation, that would be 160, and I have 4 plus 1 is 5 VA equals 160. There you go. What is VA, which is my Thevenin? is 2 times 16, 32 volts. Beautiful. So Thevenin is 32 volts. Now I'm trying to just write everything down and try to form my equivalent circuit. Thevenin is 32 volts from here, and if you remember, our Thevenin is 8 ohms from here, this point, okay? So my circuit is now 32 volts in series with 8 ohms, and then I have port AB. So all those elements to the left of AB is now replaced by Thevenin voltage and Thevenin resistor. From here, is there another equivalent circuit? Yes, I'm gonna just convert it to Norton equivalent circuit. If you guys remember, the Norton current is the Thevenin voltage divided by Thevenin resistor from Ohm's law. That would be 32 divided by 8 is 4 amps. What about Norton resistor? Easy. That's the same as Thevenin resistor, which is 8 ohms, sorry. So the Norton equivalent is 4 amps in parallel with 8 ohms. And again from here it goes to port AB. If you guys remember, we tried to solve our problem from port AB. The equivalent circuit seen from here. So these two circuits are actually equal. I want to just try to find this circuit. This time I'm gonna directly try to figure out the Norton equivalent just to prove that we've been on the right track. Okay? So I just put my circuit here again so that I can this time try to find the Norton current, Norton equivalent circuit for this circuit. So if I see my circuit from this port AB, so again I'm going to put an I here, and I see my circuit from this port only, this time I'm going to just get rid of everything to the left of port AB and replace it with a current source, which I'm going to call Norton current, in parallel with a resistor, which I'm going to call Norton resistor. And this point is the same point as AB. Okay? So first off, let's try to find R Norton. Do I need to resolve this circuit to find R Norton if I've already figured out R Thevenin? The answer is no, because the Norton equivalent resistor and Thevenin equivalent resistor are the same. So I already know that Thevenin equivalent resistor is 8 ohms, so that would be the same as my Norton resistor. So the first thing found very quickly, and that's 8 ohms. Now what I need to figure out is my Norton current. In order to find Norton current, I need to short circuit the port, then try to figure out ISC, which is the short circuit current. So let's just follow this wording. I have 25 volt voltage source, and then 5 ohms, 20 ohms, 4 ohms, and this is my port A, and over here port B. This time I'm gonna short circuit the port, go all the way down to the beginning of my circuit. I have a 3 amps here. Okay, and this short circuit current this time is what I need to find, which is the same as my Norton current. So I have 4 ohms here, 20 ohms here, 5 ohms here, and 25 volts here. Okay? So if you find the ISC, which is the short circuit current at port AB, that would be the same as your Norton current. And as you notice, this time I have included 4 ohm resistor because the circuit is not open this time. It's actually short circuited. If I short circuit this port from here, then I need to figure out the current flowing into 4 ohms as my Norton current. Okay, now let's try to figure out how we can solve this problem. Again, two popular methods to be used is KVL and KCL. Let's brainstorm this circuit together. Can I use KVL for this circuit? If I look at this loop over here, the answer is yes. I can use KVL as there is no current source here. But what about this loop? Can I use KVL for this loop? No, I already know the value of current in this loop, which is 3 amp. So if I know the value of current, or in other words, if we have a current source in a branch, there is no value using KVL method for that branch. So I'm gonna just skip KVL. What about KCL? Let's have a look at this node A. So these parts are all same potential. So from node A, I can just find the value of current flowing into 5 ohm resistor, and then another current goes vertically down to my 20 ohm resistor, and then I have 3 amp flowing into node A, and look at this one. Yeah, I can find the value of all currents flowing out of node A or flowing into node A. So that's a perfect method to use. KCL at node A gives me a lot of information. So let's consider the current going out of node A if we don't know. Again, if and only if we don't know the direction of current. So we always consider it going out of node A. So for this current, which is flowing into 5 ohms going into 25 volt source, I have VA minus 25 divided by 5. For this current going vertically down, I have VA divided by 20. And then for this current going out of node A towards port AB, I have VA minus this part is my reference voltage, which is 0, divided by 4. And do I have anything else? Yes. I have 3 amps going into node A, so I'm gonna just bring 3 amp to the other side of my equation. Equals 3. Perfect. I have just one equation, one unknown. Can I figure out VA? The answer is yes. So let's just multiply both sides by 20. So if I multiply both sides of this equation by 20, I have 20 divided by 4, which is 20 divided by 5, which is 4. So 4 times VA minus 4 times 25, which is 100, plus 20 and 20 cross out. I have VA plus 20 divided by 4, which is 5. So 5 times VA equals 20 times 3 is 60. So over here I have 5 VA plus 4 VA plus VA, which is 10 VA minus 100 equals 60. So I can bring 100 to the right side and I just reverse the sign. So 10 VA equals 160. In other words, VA is 16 volts. VA is 16 volts. If I have VA, is there a way to figure out my short circuit current flowing into port AB? The answer is yes. So this voltage, you see the voltage of this node is nothing but the same voltage of VA. And from Ohm's law, I know that ISC is the same current flowing into 4 ohms. So from Ohm's law, I know the current flowing into 4 ohms resistor is the voltage across 4 ohms divided by the resistor, which is 4. So the voltage is VA minus this side, which is, if we follow, you see, it's the reference voltage, it's 0. So VA minus 0 divided by 4. I have VA, it's 16. So 16 minus 0 divided by 4, which is 4. There you go. My ISC, which is the same as my Norton current, is 4 amp. Now, let's go back and see if our findings align. So, I figured out I Norton to be 4 amp. And in previous method, I figured out the Thevenin voltage from here. So that's the Thevenin resistor. Yeah, the Thevenin voltage was 32 volts and the Thevenin resistor was 8 ohms. And then I figured out the Norton current to be 4 amps over here. Yes, everything aligns. So I actually solved this problem using 2 different methods. If I am to just form the circuit, so the Norton current is 4 amps in parallel with Norton resistor, which is nothing but the Thevenin resistor, 8 ohms, and that goes to port AB. Again, from here, if I am to just convert Norton equivalent to Thevenin equivalent, all I need to do is just to multiply my Norton current, is 4 amp, is my Norton current, times my Norton resistor to figure out my Thevenin voltage, which is 4 times 8, 32 volts. And then, what is the Thevenin resistor? It's exactly my Norton resistor, 8 ohms. And here is my port AB, and I am seeing the circuit from port AB. Beautiful. So today we solved a circuit problem using Thevenin and Norton equivalent, and I showed you how we can interchangeably use either of these 2 methods and convert it to the other one. Thank you very much for watching this session. Please, if you like the contents that I provided, do like this session and subscribe to my channel, and please introduce it to your friends, and let's help each other grow. Thank you very much. Have a good one, and bye.